The 1934 Chrysler Airflow was the first production car ever designed in a wind tunnel. Its impact was far greater than the sales figures suggest, reportedly even impacting Porsche's designs. How aerodynamic could this car from 1934 be though? To find out, we did a simulation of it. Despite not having any modern aerodynamic features like a diffuser, wheel spoilers, or even a slanted hood, the flow stays remarkably attached, even down the back, which slopes almost vertical. That's really hard to do and impressive. But given how much the flow at the rear dives down, this is a clear indication that a lot of lift is being produced, and in fact, the lift coefficient comes out to be 0.37, which means that this car is unstable at high speeds. The flow stays attached over the underbody, which given how blunt the front is also very impressive. The main drawback of this car is the angle of the windshield, which is very steep, which makes the flow crash into it, as well as make the A-pillars quite vertical. These are both bad for drag. Looking at this plot, which shows the drag, the red hot spots show bad regions, so just under the front grille, over the nose of the hood, and at the back of the roof sloping down, as expected. But surprisingly, near the back of the underbody, the drag is so low that it is even negative, which means that this part of the car is actually producing thrust and reducing the car's overall drag. Looking from above, we get a great appreciation of just how streamlined the car is, with the flow parting at the front, traveling around the car without much separation, and then joining again at the back and forming an incredibly small wake. This wake is better than most cars today. Looking at the flow around the cabin, the front windshields are angled to help the flow part, which then travels around the car very nicely. Looking at the vortices created, there is only one very large vortex loop dominating the wake, and this loop forms because the car is producing so much lift. So the flow under and around the sides of the car rolls up at the rear and forms this vortex loop. The front wheels could use some work because some vortices are being created there, and it probably would have been better to cover the wheels at least partially. So what did the drag coefficient of this 1934 car come out to be? It comes in at just a 0.31, which is phenomenal for a time when automotive aerodynamics was non-existent. Imagine how much lower this number would have been if they even had the basics of modern automotive aerodynamic knowledge. Peace out, amigos.